Well, thank you, everyone. Good morning. Thanks for your attention. And sorry, I can't be there in person. So I'm just talking today about some work we've been doing with, routine-ish work with altimeters and buoys, but there's still very much bread and butter of long-term wave sea state variability and a lot of work we do in that area. This is work I've been doing at National Oceanography Centre with Christine, and has been funded by ESA, National Oceanography Centre. And I suppose it came out of work with Sentinel-6 JTEX project that was led by Craig Donlan, but has sort of moved on a little bit. So there's a lot of interest in looking at the coast and using in situ data at the coast, but it tends not to be exploited in larger scale analyses, especially where we aggregate large amounts of data from in situ buoys, primarily because co-location is challenging and there's more steeper sea state gradients. Altimeters can sometimes have issues and so on. And so a lot of data is sort of routinely ignored. And I've been looking a bit more closely at that, and there's plenty of other motivation to do so, including some quite nice higher quality in situ measurements from networks like CDIP, like the Channel Coastal Observatory in the UK, so it's National Network of Regional Coastal Monitoring Programs, where quality assurance is a higher priority, and they tend to use consistent platforms such as data wave riders, rather than this sort of hodgepodge of platforms you might get just distributed globally. And also, of course, we're very interested in various aspects of coastal research, from impact to physical coastal processes. And that's a great place to exploit altimetry if you can, and remote sensing. So what happens if we try to do that on aggregate? Here's an example from Dode et al. 2020. So this was part of the first phase of the Sea State CCI, which, as you probably know, is now operating in a second phase. Here's an example of two panels of the differences when you filter out buoys. You try to sort of intercompare with altimeters, and you filter out closer to the coast. In fact, 200 kilometers is the threshold here, and you can see that performance statistics are considerably degraded, or comparison statistics. And there's a lot of sources of uncertainty that are getting included there that we really can't say much about without a much more detailed analysis. It could be things like representativity, environmental error. There's a recent paper of Jung 23 that is co-locating in that kind of with those kinds of challenges. But those kinds of studies also tend to overlook some issues like maloperation of buoys. Are the buoys actually giving you the right data? And that's something that's not considered routinely as well. And obviously, in this context, that kind of intercomparison is not suitable for mission intercomparison and larger scale aggregate studies, as we're just clouding the results that we're really trying to get at. To look a little bit more in detail at the kind of variability across buoy platforms available, I've taken a region here in the North Pacific, the Eastern North Pacific. Sorry, the map's a little small there, but you can see there's a large number of buoys, some offshore and a much larger number closer to the coast. And the figure on the right is a timeline of operational availability, and the colors indicate the operating agency. So as you can see, there's a whole range of platforms potentially available, but only the bottom few, which there's a black line dividing those near the bottom there. And you can see that there's maybe 3 or 4 times as many buoys lying much closer to the coast, perhaps within 50 kilometers or less, that wouldn't typically be exploited, but could be available. But there is also a whole load of information, and I'm using some metadata as well there from the recent Hall and Jensen USACE quality controlled and consistent measurement archive for NDVC, which gives you a greater insight into potential problems such as changes in payload, reliable data, changes in hull type, lots of, and specific locations. Drift is obviously a factor, but nonetheless, it's a bit of a mess, and we're basically sort of, when we use these ensembles of buoys, I think we tend to forget that it's really a collection of independent platforms. When we compare that to something like an altimeter, which is basically doing the same thing everywhere, consistently, whether it's maybe perfect or not, there are these qualitative differences between the data sets that tend to get overlooked. So there's lots potentially we can do, and again, I don't see a whole lot of this being done. And here's an example of how we can interrogate, using the altimeters to interrogate the buoys, actually, to see whether there may be problems, and whether we might want to use them, and how any uncertainties might be contributing to those larger scale aggregate analyses. So what I've done here is just taken a load of into comparisons of HS mean bias from this set of buoy offshore. This is actually offshore buoys in that region, and derived, just bootstrapped a sort of estimate of the probability of observing any of those mean biases, and then doing that site by site for each buoy, which are the panels on this figure, and there's a panel for each buoy. Now, there were 9 sites. 2 of those actually omitted because they don't have any adjacent tracks close enough. So this is data from Jason 3 for about 5 years, I think. And the blue lines are the observed mean bias at each site, and you can see that there's a bit of a spread there and 1 or 2 outliers. But the top right-hand one that I've highlighted in particular is somewhat unfortunately, perhaps the wave rider at station Papa, WMO 46246. We see a really substantial mean bias at that particular site, which looks highly anomalous and isn't immediately explained, and we're still not quite sure about that. But it's surprising when these are sites that are routinely used, and it's surprising when you take a closer look that there are some quite suspicious sort of artifacts out there. So that's kind of a question there, and there's more here that I won't talk about, but other issues. So we can also then use the altimeters to look more closely, for example, and there's a heap of information even just from Nadir altimeter long track data, down to pretty high resolution. I'm binning this just basic 1 Hertz LRM data from Jason 3 here, a long track. At that site, so this is at Station Papa, and I've plotted some statistics. Again, mean bias, HS mean bias on the left, derived from those sort of binned 1 Hertz along track data, and correlation on the right hand side, and I've broken those out seasonally with the northern hemisphere summer months on the top and the winter months on the bottom. And the issue we can sort of see here that there isn't in this case really any gradient at play, which is probably what we'd expect way out in the ocean, but that mean bias is negative everywhere, and it looks highly suspicious. Whereas on the other hand, the variability is being captured pretty well, as we'd expect, with very high correlation values. So we start to build up a picture of the properties at any individual site, and some of this has been recently submitted into remote sensing. So I'll go on with a couple more examples and then move a bit closer to the coast. One of those other offshore sites, again, some more interesting information pops up. We're sticking with mean bias on these left-hand panels here, and we see that the mean bias changes with season, changes sign, in fact, which to me doesn't stand out as being particularly clear. Why? We have a track which is pretty close. I think I may have omitted this. Is the black circle is 100 kilometers. so that the inner grey circle is actually within about 25 kilometers, so it's pretty close to the buoy. So representativity error isn't a major problem here, and we're certainly seeing the gradients, but there's not a really clear explanation as to why we see sign change in seasonally. And of course, if we're averaging over annual data, then these kinds of properties are going to be averaged out and add to the kind of uncertainty and also remain largely unknown or unexplained. Okay, so that's kind of the picture offshore. So we're already finding a lot of interesting information with a closer look. What do we do closer to the coast? And some studies have kind of started to tackle this problem. There's a recent study by Buoys et al. Looking at a global kind of altimeter buoy matchup study. Employed essentially a methodology based on distance to coast. There's a bit of earlier work by Nearchore and Quarterly, which I feel like I'd overlooked a little bit until more recently, but they have a very detailed approach closer to the coast, employing the data from the Coastal Channel Observatory in the UK. And the approach there was to employ a model, a high resolution sort of hindcast, to establish areas of representation around buoys to inform the match-up process so that these gradients and misalignments are not problematic. And by defining statistical thresholds, they could then sort of select buoys and match up appropriately with respect to altimeters. And that works probably quite well, but you may not always have access to a model. And so perhaps maybe we can just use altimeters in a similar kind of way. So sticking kind of with the theme that I was just talking about, using the altimeters in this way, we can, again, just using LRM data, move close to the coast, and there is plenty of data potentially available all the way up to maybe, you know, a few kilometers, depending on what altimeter data source you're using. And again, this is within that region I showed earlier in the North Pacific. A couple of examples. It doesn't take very long to start finding problems. The left-hand panels there, sticking with mean bias, is another example where we have no representativity error with a track that coincides very closely, and that is showing a positive bias in both the summer and winter months. So again, quite suspicious data. And on the right-hand side, a slightly more subtle example where the mean bias, which is the white color or the palest color along track, actually you may be able to notice sort of shifts. It moves offshore with season, and so perhaps, you know, we've got some kind of coastal processes changing there with season, or something's going on, some kind of currents maybe that's affecting the buoy. And that would, for example, call into question a methodology whereby we were using distance to coast, because it seems that the properties are temporally a function of distance to coast. And that would add, again, some uncertainty into any subsequent analysis. So with this in mind, it seems eminently possible that we could take an approach like Nearchore and Quarterly without the model. We could derive some statistics in a kind of, it feels like a kind of machine learning way, and I think I'm kind of getting there with that, to define a collocation, a kind of match-up approach that would then allow us to incorporate these, say, coastal or nearer shore sites into these larger scale aggregate analyses, so we can do into comparisons at a larger scale with altimeters and buoys. There are a lot of other altimeters available. I was hoping to have used a few more, but I haven't quite got there yet. But I will draw your attention to studies such as Passaro et al. 23 that is looking at the Sentinel-6 SAR mode delayed Doppler altimetry, where we can get even higher resolution and more data availability in these coastal regions, going beyond just the LRN I'm showing here. So lots of potential to examine these sites in detail. And that's with that essentially concluding where we're at. So there seem to be already quite a number of important points coming out of this work. Buoys may be problematic, and I'm not sure that that's really being considered in a lot of studies, but can be interrogated with altimetry in the ways described here, or fairly relatively straightforward fashion. There's lots of spatial information available through the altimeters. And it seems to me that although there are a large number of buoys potentially, there may not be so many that we couldn't work site by site now, and so we could provide that information back to the community and to buoy operators that may be interested that there is suspicious operation. So I think that's the kind of direction we're moving in, to have a much more refined experimentation methodology that could exploit a lot more of this data that we have closer to the coast. So I think with that, I'll conclude and take any questions. So thanks for your attention.